up, guys? So this tutorial is on engineering notations, and let's get started. In yellow, the yellow chart, you will notice that there are metric prefixes and there are powers of 10, right? These are your metric prefixes. These are your negative prefixes right here. These are your negative prefixes: pico, nano, micro, milli. All right, these are your positive prefixes: kilo, mega, giga, tera. The symbols, all right, you can see the symbols P, N. This is a weird symbol. This is called mu. This is called mu. All right, it's a Greek symbol. It's for micro. It's a special symbol. This is the only symbol that is different from a letter. All these are just regular letters, right? All right, then you have kilo, mega, giga, tera. Let's look at the values for each notation, for each prefix rather, right? Each prefix has a value. The negative notations will have a negative sign before the value. The positive notations, well, they have a positive sign, but positive is not shown here. So negative 12 pico, right? This is negative 12 pico. Negative 9 nano, 9, they rhyme, right? Negative 6 micro, like Microsoft, negative 6. All right, milli, negative 3. Then you have kilo. Kilo is your first positive engineering notation. Kilo with a K. That's the 10 to the third power. All right, mega, 6, 10 to the sixth power. Mega millions, mega, same setup. Then you have giga. All right, gigabytes, gigahertz, 10 to the ninth. And then tera, 10 to the 12th. So nowadays our storage capacity has moved on to terabytes, so that's what you see a lot. TB, 2 TB, 3 TB, whatever it is. All right. So powers of 10 is very important to know. You must know the powers of 10, the values. You must know the symbols and the name of the prefixes, just so you can communicate. All right. These three things have to be known. What you really need to do is just remember the prefixes, right, and the symbols. If you can remember the prefixes and the symbols, you will be in a good position. So you need to remember this guy right here, this set, and you need to remember this set. All right. To help you guys remember, I created this statement. It's a little silly, dark, violent, maybe even, but it helps you remember. It helped me remember. It helped a lot of my students remember. All right, so let's go over the statement. The statement says, the gruesome man killed Maxwell under Nick's porch. Now this starts off with positive notations. This first T is actually tera. All right, so let's do that. So this first T is actually, the value for this first T is 10 to the 12th. All right, gruesome is giga. The value for this is 10 to the ninth. These are all positive notations, guys. Man, this is mega, 10 to the sixth. Killed, K, kilo, right? This is kilo, this is 10 to the third. All right. On the second line, everything is in negative. All right, it's a lower notations, the negative notation. So Maxwell is actually milli. All right, 10 to the negative 3. Negative 3. Under, this is a U. Again, this is a weird shape looking weird symbol. It's micro. The symbol is known as mu. So this is a micro symbol. It's closest to the letter U in English language, so we'll use the letter U for this. This is 10 to the negative 6. Nick, nano, negative 9. All right, 10 to the negative 9. And finally, P is pico, porch, 10 to the negative 12. All right. So if you can remember this statement in order, you'll know your prefixes from positive notations, from the highest positive notation to the lowest negative notations. After you have memorized the metric prefixes, right, and their powers and their values. Once you have done that, the next important thing is something very basic that a lot of people overlook is the ability to identify where the decimal point is. Engineering notation is all about moving the decimal point, and they have to be moved in threes, right? You got to move them at least 3 times, 6 times, 9 times, 12 times, right? It got to be in increments of threes. It cannot be once, twice, 4 times, 5 times, right? Increments of threes only. So I will set up a few numbers here. I have letter A, B, C, D, as you can see with numbers here, and the units: ohms, V for volts, A for amps, W for watts. You should know this already. This is prior knowledge information. All right, so let's take 1800, right? Where is the decimal in the number 1800? Let's examine this a little bit. The first thing you gotta do is locate the decimal point, right? 1800. I have 1800 ohms. So where's the decimal point in 1800? Look closely. Can you see the decimal point? If you cannot see the decimal point is always going to be at the end of the number. The end of the number is here, right? Right over here. So you cannot see it. That means it's at the end of the number. All right. So now this is where we'll start our conversion process. So the next thing we have to look at is this number 1800 higher than 1 or lower than 1, right? It tells you in number 2, if the number is less than 1, you will use the negative prefixes. Well, is the number lower than 1? No, it's higher than 1. So what do we do if it's higher than 1? If the number is higher than 1, right? Number is higher than 1, you will use the positive prefixes. Positive prefixes, that means we'll use one of these bad boys over here. Right here, one of these guys over here, right? So let's see which one we use. Remember, you gotta move it in increments of 3. So let's say you wanna use kilo, right? Let's say you wanna use kilo. Let's say you wanna use kilo as a prefix. Well, here's number 4. Decimal movement must correspond to the prefix's power of 10. If you wanna use kilo as a prefix, you gotta move the decimal point. How many times? How many times? Right here. It tells you right here. Right? 3 times. We'll move it 3 times. So let's move it 3 times. Let's see how it works out. So here's my decimal. Right? I start over here. Move it 3 times. We'll go to the left. 1, 2, 3. Boom. We place it here. So now we can use the letter K for kilo. So my answer is going to be 1.8 kilo. The unit comes down. Ohms. All right, 1.8 kilo ohms. Now let's solve for B. Let's solve for B right here. All right, what does B say? B, the number for B is what is it? 350. And then what? We have 6 zeros after that. Right? 6 zeros. And what's the unit? Volts. Unit is volts. I'm gonna move the screen up a little bit, okay? Now, where is the decimal point here? Locate the decimal point. Can you tell me where the decimal point is? That's number 1. See, number 1 says locate the decimal point. So where is my decimal point? Where's my decimal point? Can you see it? Is it here? Is it here? Can you see it? If you cannot see it, where is it supposed to be? It's gonna be all the way at the end. All the way at the end. Right here. Right here. Alright? Now, next piece. Is the number less than 1 or higher than 1? Is it less than 1 or higher than 1? Well, this number is clearly higher than 1. So what do? We gotta use one of the positive prefixes. Look at the number of zeros here, right? So which prefix do you want to use? Do you want to use mega? Right? You want to use mega? Or do you want to use giga? Why don't we use mega and see how it works out, right? So how many times do you move the decimal? 3 times? 6 times? 9 times? Well, for mega, the number is 6. So you got to move it 6 times. So let's start. We start over here, decimal point, and move it 6 times, right? We go to the left, moving left, to the left, to the left, everything to the left. Alright, so there's 3 places, right? 4 places, 5 places, and then 6 places. We stop here. If we stop here, my answer is gonna be 350, and then we substitute all these zeros with the metric prefix, which is mega. So it's going to be 350 megavolts. Now you might say, hey, why don't we use giga? Why don't we convert it to gigavolts? Yeah, you could do that. All right, but your decimal movement has to correspond to the power of 10 for that prefix. So if you want to use giga, you got to move it 9 times. The decimal has to move 9 times. So let's work that out. Let's see what that looks like. All right. So we'll do it again, but we'll do it in red here. So we have 350, right? Right. This is my value, and now we're gonna use what do you call it? We're gonna use giga, right? So we're gonna move it 9 times. So where's my decimal here? It hasn't moved. It's right here, right? It's at the end. If you cannot see it, it's gonna be at the end always. So let's move it 9 times and see where we end up at. 1, 2, 3, 4, 5, 6, 7, 8, 9. We end up here. What happens now? What do we do? Well, my answer is very simple. My answer is going to be 0.35. I'm not going to write all these zeros. It's unnecessary, right? What do I put over here? What letter goes here? Giga, big G, gigavolts, right? These are both converted. The same number, right? The same value has been converted to engineering notation using 2 different prefixes. Let's just see first. So again, we'll look at the first rule, right? Locate the decimal point in the number 0.0046 amps. Where is the decimal point in this number? Can you see it? Well, if you can see it, it's right where you see it. All right? As you can see, it's right hither. So we will start our conversion process at this location from this decimal point. All right, so is the number higher than 1 or less than 1? The number is clearly less than 1. It's a decimal number. It's less than 1. All right, so we'll use one of the negative prefixes, which is right up here on top, right? We'll use either pico, nano, micro, or milli. So let's do it. So my number is 0.0046. So since it's only has 2 zeros here, let's use milli. Let's say we want to convert it to milli. All right. So if you convert it to milli, how many times do we move the decimal point? Well, we got to move the decimal point at least 3 times, right? Why? Because the decimal movement has to correspond with the metric prefix. So let's move it 3 times and see where we end up. Now, you are converting a number to notation form, a number that is less than 1. So our decimal will move towards the right, right? Decimal will move right. So we'll move this right. So we're going to move at least 3 times to the right. So 1, 2, 3. That's where we place it. So my answer is going to be 4.6. What's the letter? It's going to be lowercase m, right? Because it's milli. We moved it 3 times. Milli, and then the unit amps. This unit amps is followed up. Now what happens if we decide to change it to micro? Let's see what happens if we change it to micro. So we have, this is our number, right? 0.0046. Now, if we change it to micro, right? How many times do we move the decimal point? We gotta move it 6 times. So let's do it. All right. 1, 2, 3, 4, 5, 6. Now, since we moved this 6 times, you see some empty cups here, right? These are like little empty spots. So we fill it up with zeros. The empty spots, we fill it up with zeros. So what's my answer? Let's see what it looks like. It looks something like this. My answer is going to be 4600 microamps. Right? Look at the symbol for micro. This is weird symbol, right? This is the symbol, Greek symbol mu. Alright, let's try to do D in red. Alright, so let's write the number down first. So we have 0. Remember, guys, the first thing is first, right? You gotta locate the decimal point first. Figure out where the decimal point is at, and then you can move forward from there. So this is my number. Alright. We have the right amount of zeros. Yes, we do. Great. So where's the decimal point here? Can you locate it? Well, I see it right here. Right? It's right over here. So if it's right here, that's where we start our conversion process. Alright? Now, what do you want to convert it to? Well, first of all, is this number lower than 1 or higher than 1? This number is clearly lower than 1. Alright? So we're going to use one of our negative prefixes. Which one do you want to use? Do you want to use pico, nano, micro, milli? Well, take a look at this number. It's a pretty large number, even though lower than 1. It has several zeros. Well, it has 6 zeros. So we have a number here that is 6. So let's try to use micro. Alright, let's try to use micro here and see how we end up. What happens if you use the word if you use micro? Remember, if you're using micro, you gotta move the decimal 6 times. Alright? Let's try to do that. See what happens. So we got 1, 2, 3, 4, 5, 6. We end up here. So my answer is gonna be 0.78 microwatts. Alright, that will be the value for the number above. Now, what happens if I don't want to use micro? I want to use something else. I want to use something like nano. Let's say I want to use nano. All right. So for nano, we'll use orange. But let's say I want to use nano. What do I do then? Well, look at nano. The decimal has to be moved 9 times for nano. So let's do that. Let's work that out. What it looks like. So 0.000000078. All right. So what will that look like? Let's do it. So nano has to be 9 times. Decimal has to move 9 times. Remember that. So 1, 2, 3, 4, 5, 6, 7, 8, and then 9. Now, I moved it 9 times, but there's an empty spot right here. Right? After the 8, there's an empty spot. What happens with this empty spot? We fill it up with a 0. Any empty spots, we fill it up with a 0. So what will be my answer? What will it look like? Well, it'll look something like this. 780 nanowatts. Right? Nanowatts. 780 nanowatts. Now here we're going to convert a value that's already in notation form, and we're going to convert it to standard form or decimal form. Alright, so we're going to basically eliminate the notations here, the metric prefixes, and put them in standard form, that the way we're used to saying them. Alright, let's get to it. So let's do A first. Now, A says 1.5k ohms, right? 1.5k ohms. 1.5k ohms. I'm gonna write the k here because we're gonna be messing around with the conversion, right? But you know it's k. This is A. So k, what does k correspond to? Let's look at our chart. K corresponds to kilo, which is 10 to the 3rd power. That means the decimal must move 3 times. Alright? Now, since we're converting it to standard form, we're going to move it to the right. Decimal will move to the right. Alright, let's do it. 1, 2, and 3. We'll place a decimal here. Now, you see there are 2 empty cups, right? There's an empty cup here, there's an empty cup here. So what do? We fill it up with a 0. Boom, Boom, put that with a 0. So what's my answer? My answer is 1500 ohms. Alright, that's my answer. 1500 ohms. Let's do B. Now, B says 740 mega, right? This is big M, mega ohms. So what is mega? We'll look at mega. The chart for mega says it's 10 to the 6th. The power for mega is 10 to the 6th. We gotta move the decimal 6 times to the right, Okay. Now, where is the decimal here in this number 740 mega? Is it before the 7? Between the 7 and the 4? Is it between the 4 and the 0? Can you see the decimal? Well, you know what the rule says. If you cannot see the decimal point, right? If you cannot see the decimal point must be at the end of the number. So, the decimal point is here. Boom. This is where we must start the conversion process. Locate the decimal point, then start the conversion process. Now, M is 10 to the 6th. That means we move it 6 times. And which way do we move it? To the right. To the right, to the right. 1, 2, 3, 4, 5, 6. Place the decimal here. Now, all these empty cups you see, they will receive a 0. Alright? Put 0 on top, 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 0 on top. So, what does this look like? Well, this is what it looks like. 740 mega ohms is equal to 740 million. Alright? 740 million ohms. This is my answer for B. 740 million ohms. Let's do C and D with a different color. Alright, let's do it with orange. So look at C. Now, C is 3800 pico. This P for pico, right? Where's pico at? Pico is right here. What's the power for pico? Negative 12. That means we must move the decimal 12 times. But first, let's locate the decimal first, right? So let's write the numbers down here. 3800 pico, 3800 pico. Alright, pico amps, right? So pico is 10 to the negative 12. You must move it 12 times. Where is my decimal here? Where is it? Is it before the 3? Between the 8 and the 0? Where is it? If you cannot see it, it must be at the end of the number. Okay? With the decimals right here, guys. Now, let's move it. How many times do we move it? Well, we move it 12 times. It says it right here. It's 10 to the negative 12. Pico is 10 to the negative 12. Alright, move it 12 times. Which way do we move it? We're going to move it to the left here. Okay, remember, this is a negative number, negative value, right? Pico is negative, so we move it to the left. Alright, let's get to it. Let's move it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wow. All the way here, huh? We gotta fill up all these empty cups with 0, guys. All these empty cups go get zeros. 1, 2, 3, 4, 5, 6, 7, and 8. Alright, so we get 8 zeros here. So what is the answer for 3800 picoamps? Well, it looks something like this. Point, then 8 zeros, right? We get 8 zeros, and then the numbers. And then you could write amps. Now, when you're expressing this value, you do not have to write these 2 zeros. These 2 zeros can be crossed out, so you can express this value in this fashion. Alright, that is good enough. That is all you need to write. Alright, let's do D. Look at D now, guys. D is milli. Okay, this is lowercase m, not big M, lowercase m. So what is milli? What is the value for milli? Milli is right here. What's the power for milli? Milli is 10 to the negative 3. So let's write that. Let's write the numbers here. 6 milliamps, right? Where's the decimal here? Is it before the 6 or after the 6? Same thing. If you cannot see it, it's going to be at the end of the number. Milli is 10 to the negative 3, as it says here. How many times do we move the decimal? Well, 3 times, right? Let's do it. 1, 2, 3. All the empty spots, get a 0. Boom, boom. Fill it up with zeros. So my answer is going to look something like this. 0.006, and then the unit amps, 0.006 amps. So that's how we convert our values that are already in notation form to standard form or decimal form. Alright, now which way do we move the decimals? Left, right, left? It gets a little confusing, guys. I get it, I understand. You're kind of flip-flopping back and forth, right? Well, I have a set of rules that I kind of created that I hope helps. Right? Check this out. Right? So the first rule is to convert it to notation form. Alright? That is what we did in the beginning of the video, in the beginning of the lesson. That's what we did. Next, we're going to convert it to decimal form. That's what we just did. We just converted the values to decimal form. The first half of the video is converting it to notation form. The second half of the video is converting it to decimal form. So if you have your notebook with you, you can take notes here. Alright, or you can just kind of, I don't know, freeze the frame or whatever, however you want to do it. But these are some basic rules that I kind of came up with using very simple language to help you convert values to notation form and from notation form to decimal form. Alright, in red it's positive notations, in blue it's negative notation. Take your time, read them, and if you have any questions, let me know. Give me some feedback. Let me know how it worked out for you. If this helped, I'm gonna post some bonus questions for you guys coming up. Here are your bonus questions. Alright, the ones in blue, convert them to notation form. The ones in green, convert them to decimal form. You can post your answers on the comment section. And hope this tutorial helped. I was hoping it would be a little shorter, but came out to be pretty long. Hope you guys don't mind. Alright, you can rewind in convenience, take notes for convenience. Hope this helps. Alright, see you guys soon. That's out.